Hi, my name is Jens Kaffitz and I am the developer of Mari Extension Pack. In this video, we will take a look at the new node types introduced in Mari Extension Pack 6R3. The new AB compare mask node generates a black and white mask by comparing the values of these two inputs with each other. You can compare the values based on one being larger or smaller than the other, or if they are identical, in which case you can also set a tolerance. Finally, you can also tweak the overall softness of the result. The node is useful to create a simple blending of materials based on their bump or displacement values. Here in this example, I have two materials. If I feed the displacement outputs into the AB compare mask node and its output as a mask into the multi-channel merge node, I can then use the displacement strength of each material to push the materials through each other. You may already know this functionality from Extension Pack's height blend node. In fact, the height blend node and the new AB compare mask node share situations where they could be used interchangeably. However, the height blend node is overall more computationally expensive since it has more options and does additional interpolation. While results this way can be cleaner and give you more flexibility, it can also add complexity and make things more difficult to control. The AB compare mask node, on the other hand, is a very simple value comparison, making it very predictable. As part of Extension Pack's new node context menus, a convenience option to create either a height blend or compare mask setup has been added onto multi-channel merge nodes. So here again I have my setup of two material nodes. If I select the multi-channel merge node and press Ctrl and space, I have two options to create either a height blend or compare mask setup automatically. The checkbox down here determines if the setup will be attached to the displacement port of the materials or the bump output. Using this context menu option, you can then quickly create a height blend setup with a single click. Both of these options are also available in the node creation hotbox on the hotkey C, and dedicated hotkeys also exist for both tools. Another mask creation option is the orientation mask node. The node is purpose-built to isolate downward or upward-facing geometry with the tolerance. It can, for example, be used as a multiplier over an ambient occlusion to just get a contact mask of down-facing occlusion, allowing you to place dirt and drips better. You can amend the computation by feeding in a tangent space normal map to also evaluate modified normals and add the effect to normal map details. The next new node type in Mari Extension Pack 6R3 are image sampler nodes. Looking at their node properties, we can see all they contain are a single image attribute you can assign a map to from the image manager. If we look at its output, however, all we get is this uniform color. Image sampler nodes do not compute the assigned image against the geometry, but instead transmit the actual image object from the image manager via their output port. We can then attach that output to nodes supporting image sampler inputs to keep the image separate from its projection method. Let's take a look at the axis projection node. You will find a new image sampler input port down here. If I attach my existing image sampler to it and view the output of the axis projection, you can see I am now applying my image sampler image with a triplanar projection, even though the actual image slot inside the axis projection node remains empty. Other node types supporting the new image sampler are, for example, the tiled extended node, cylindrical projection, tiled infinity, and image nodes, allowing me to share the image used from a central node into as many other nodes as I want. The last new node in Extension Pack 6R3 is the Paint Drips 2D node. The node allows you to create procedural drip effects. You can even animate the node by attaching an animation node to its time offset input, and in the Mari Play Controls toolbar, hit the play button. The node itself has many customization options, and we won't cover them all here. However, the attribute tooltips should give you a good idea of their functionality. By default, the node operates UV based. However, you can convert it to a projection by attaching the UV and mask outputs of a projection node to the ports with the same name, and then use, for example, the transform tool to position it.